All right, guys. Today we're going to continue on trigonometry. We're going to be talking about a very simple part of trigonometry. It's actually part of geometry too and algebra. It's similar triangles. Before we can really dive into trigonometry, which is triangle geometry basically, we got to make sure that you got everything that you need, all the tools with angles and degrees and triangles. So as far as similar triangles go, guys, let's talk about the classification of triangles. And the classification of triangles is so easy. You guys have pretty much all seen this throughout your life already. A scalene triangle is a triangle that has no equal sides. Sometimes you'll see them marked like this. Okay? And what that means is, since I only have one tick mark here, 2 here, and 3 here, I don't have the same tick marks on any of the sides. So what that means is that none of the sides are equal. If I had the same tick marks on 2 or more sides, that means that those sides are equal. For example, let's look at an isosceles triangle. An isosceles triangle is a triangle that has 2 equal sides. So one tick mark, those sides are equal. That is called an isosceles triangle. An equilateral triangle is a triangle that has all equal sides. Done. Okay? That's how you classify triangles by side. If you want to classify them by angles, an acute triangle is a triangle where all of the angles are less than 90. I don't know why I didn't draw one up before. I'll do one now. Boom, right there. An acute angle, remember that acute means less than 90. So here all of these angles are less than 90. This could be 60 and that could be 70, for example, and then that's going to be 50. That's fine. It looks like an equilateral, but for it to be an equilateral, I cannot assume. I would have to say that this, and this are equal first. And if I did say that, sir, then 100% you're right. If it was an equilateral, which again, I don't even know if I drew one there, but let's just say that I put the markings, then this would be 60, 60, and 60. So yes, an equilateral triangle by side definition is also an acute triangle by definition of the angles. And when all the angles are the same, might as well, since we're here, we're talking about angles, if they're all the same exact angle, it is called equiangular. So if all the angles are equal, it's called equiangular. And just so you know, if you have an equiangular triangle, it's also equilateral, and vice versa. If you have an equilateral triangle, they're also going to be equiangular. Remember how we were talking about the angle and side relationship? Remember how we said that when you have an angle, let's say this is 50, let's say that's 80, and let's say that's 50. I didn't want 50. Hold on. Let's do this as 30, and then that's 70. Remember what we said, guys? That the side across the 80 is the largest, then the side across the second largest is the middle, and the side across the smallest angle is the smallest. If that is true, then if I have an equiangular triangle and they're all the same degrees, doesn't that mean that all the same sides are equal as well? Okay, so that's why that works. A right triangle is a triangle that has literally exactly one right angle, and that's that, period. One right angle. I have to denote that right angle. Don't ever do this. Oh, Mr. Morrow, that's a right angle. Yeah, that's a right triangle. Yay! That will be wrong. You can never assume in geometry or trigonometry, ever. You cannot assume, but Mr. Morrow, that is a right triangle, man. It is if I tell you, I give you an indication. Okay, guys? On the SAT and the ACTs and all those tests, they're going to have things that look like one thing but are really something else when you prove it. Okay? So please be careful of that. If it has exactly one right angle, it's called a right triangle. Obtuse triangle. An obtuse triangle, gentlemen, is a triangle that has one obtuse angle. Literally. And obtuse is greater than 90. So let's say this was 105 degrees. Okay, that would be an obtuse triangle. Yes, sir. There's a little thing like this, you mean? Yeah. Okay, I could go like that if I wanted to. Sure. Absolutely, my brother. Absolutely. Thank you. So now that we know a little bit about triangles, let's talk about similar triangles, friends. Because similar triangles are something that are so important. You're going to see it a lot, not only in this class and next year and the year after, but you're going to see on the SAT and the ACTs. And if you ever get into building construction or architecture or engineering, that is going to come back. Programming, that's going to come back a lot, okay? You're going to have to know similarities. So similar triangles are defined as such. Similar triangles are triangles that have equal corresponding angles. Let me first show you how to define corresponding angles and sides. If I were to tell you that triangle ABC is similar, that's the similar symbol, by the way. That is similar. If that's similar to triangle A prime, B prime, C prime. Check this out, guys. You never, ever, ever, ever choose corresponding sides by the pictures. In these particular pictures, it's very easy to see the corresponding sides. But what if I did this to you? Okay? What if I did this? And I spun it. Sometimes it's not as easy to know, oh, whoa, wait a second, what corresponds with what? So I never teach how to correspond by picture. I always teach how to correspond by the actual letters they give me. And let me show you how easy it is. A corresponds to A prime. It's that simple. First letter to first letter. B corresponds to B prime. C corresponds to C prime. That simple. Okay? So, for this to be similar, angle A must be congruent to angle A prime. Angle B must be congruent to angle B prime. And angle C must be congruent to angle C prime. Just the way it has to go. And then, similar triangles have proportional corresponding sides. Let's look at the corresponding sides. You're going to go AB to A prime B prime. So AB will correspond to A prime B prime. Not because I looked at it and it looks that way, but because the letters tell me so. BC to BC prime. BC corresponds to B prime C prime. Not because of the figure, but because the letters tell me so. And then, last but not least, A to C corresponds to A prime to C prime. Does that make sense, my brothers? Yes, sir.
How do you know a triangle is prime?
Prime just means that's the new, it's a new figure, a new letter, a new. I could have called that DEF if I wanted to. Okay, thank you, my brother. All right, so let's see what I'm talking about, proportional. Let's make this, whatever, 10, 20, and 30. And let's make this a 2, a 4, and a 7. Okay, AB corresponds to AB prime. So 10 to 2 better equal BC to BC prime, which is 20 to 4, which better equal AC to AC prime, which is 35 over 7. And all of those equal 5. So all of the sides are proportional. Because similar figures are figures that have the same shape, same angles, but different sizes. Does that make sense so far, guys, what the definition of this is? Okay, now let's get to it. Let's get to the meat and potatoes. Okay, find the missing side of the similar triangles below. Okay. We know that A to A prime, B to B prime, C to C prime. What corresponds to AB? I mean to A prime, B prime? 8. Okay. So give me one fact ratio. For example, doesn't 10 correspond to 20? So if 10 to 20, if these are proportional, then doesn't 8 have to correspond to C in the same fashion? Do you see what I'm doing here, guys? Cross multiply. So I got 10C equals 160 divided by 10. C equals 16. Done. How do I find B? Well, same thing. Let's go 10 to 20 has to equal 6 to B prime. To little b rather. So that's 10B equals 120. B equals 12. Does that make sense, guys, what we're doing here? Yes, sir. Okay, if you see it, of course, you could have seen this, guys, and you don't have to do the work. I always start with simple numbers. I could have put square roots in there or decimals or fractions. If you see it, of course, God bless you. Great. If you don't see it, you got to work it out. But do you see how to work it out? Take a corresponding side of one of the triangles, put it over the corresponding side of another triangle that's given. Then, the side you want to look for, in this case, 8 to C. Now, if you want to go backwards, if you want to go 20 to 10, then you have to write it C to 8. And you're still going to get the same exact answer. You got to go from one triangle to the other, and then stay with the original triangle to the other to find the missing side. Does that make sense? Yeah. Okay. Let us continue. Let's find this. This one should be pretty Mickey Mouse. How does AC to A prime, how do they differ? How does AC to AC prime differ? By 3, right? It's divided by 3, right? So if they're similar, which I said they are, they all have to be proportional, correct? Yes. So 24 divided by 3 is? So C is 8. Why? Because AB corresponds to A prime, B prime. What's 15 divided by 3? So A is going to be 5. Why? Because BC is corresponding to BC prime. Pretty simple, right? Not too bad, right? Told you guys would like this one. Pretty easy lesson. Let's do a couple more examples and we're done. May I? Okay. Now, John wants to find the height of a tree in order to rent a correctly sized lift. Lifts are those things that are hydraulic and they put you, it's like an elevator but for the outdoors, and they take you up high as you can. There's different types of lifts. There are lifts that go to 20 feet. There are lifts that go to 100 feet. There are lifts that go to 50 feet. Before you go somewhere and rent it, don't you want to know how high you have to go? Because it would stink if you spent because there are a lot of money to rent. Let's say you spent a couple $100, didn't do your math correctly, and you only got the one that goes 20 feet and you need to go 27 feet. You're out of luck there, aren't you? And you wasted a lot of money too. So this is where it's pretty darn useful. So he wants to cut this tree, so he needs a lift for the tree. In order to find the height of the tree, he placed a 4-foot stake, which is this guy right here. Sorry, I tried to make it pretty, but it didn't come out that pretty. There's a 4-foot stake there, okay, in the ground, and measured its shadow, which is 2.25 feet. So this little triangle that I have, well, it's in black, but whatever. The shadow is 2.25 feet, and the stake that I dug into the ground was 4 feet. Okay, that's what I know for sure. I can look at those facts. I can calculate that easily. I can also calculate the shadow of the tree. If the tree's shadow is 24 feet, I want to know how tall is this tree, man? Well, guess what, guys? If you connect the horizontal and the vertical, that's a 90. That's a 90. I have similar triangles now, don't I? Okay. So let's check this out. Yes, sir. No, I'm not assuming anything. A vertical with a horizontal by law creates a 90, sir. Thank you, my man. Thank you. Now, let's do this, guys. Doesn't x correspond to 4? And isn't that going to equal 24, which corresponds to 2.25? Okay. Now, I didn't say this is going to be pretty, but it's doable. So you're going to cross multiply, and that's 2.25x equals, here, I'm not even going to use the calculator. That's a 96 divided by 2.25. Now I am going to cheat and use the calculator just because I only have a few minutes left. So I'm going to cheat. 96 divided by 2.25, bam, equals 42.6 repeating feet. So basically, I'm going to have to get the one that goes at least to 45 or 50 feet, aren't I? Sir. How did you set it up, Apple? Okay, you could have done that too. X to 24, it's still going to equal 4 to 2.25. There's a lot of different ways to do this one. You could have gone x to 4 equals 24 to 2.5. You could have gone 4 to x equals 2.25 to 24. Or you could have gone x to 24 equals 4 to 2.25. Awesome. Awesome, dude. Doesn't matter which way you do it. Choose a way and stick to it. You know what I'm saying? Does that make sense, guys? And I know you think, oh, but I'm never going to do that. Wait till you have a family and your wife tells you, hey, the tree, you're going to want to take care of your family. You're going to do it. Because trees, if they get too tall, guys, especially where we live, hurricanes come, they topple them over. You can destroy your house. That's where your family lives. So don't think of this as just a stupid math. This is an actual practical math that you can actually do. Okay? Now, let's say Mark is 5 foot 3 inches tall and has a 3-foot shadow. So this dude is 5 feet 3 inches. I did this on purpose. I'm going to show you the conversion now in a second. And he has a 3-foot shadow. How tall is the telephone pole if the shadow is 22 feet? Okay. First of all, this little apostrophe, that just means 3 feet. Now, this 3 inches part, I got to turn it into feet. How do I do that? How do I go from inches to feet? Divide by 12. Very good. Remember, when I'm going small to large, I divide. When I go large to small, I multiply. So 3/12, so that's 1/4, right? It's a quarter. So that's 5.25. So I want to find the height of that telephone pole. What am I going to need that for, Mr. Morrow? I work for FPL and I got to go fix something at the top of the telephone pole. I need to know how high it is. I have to. Okay? So I'm going to have 5.25 to x equals 3 to 22. I'm going to cheat because I only have a few minutes. Times 22. 5.25 times 22 equals 115.5, which equals 3x divided by 3. And x equals, divided by 3, 38.5 feet. And there it is. And that, my friends, is similar triangles. Thank you very much and have a great day. God bless you. Homework is valid.